Okay, so basically in today's lecture we are going to start something which is called as ionic bonding. What an ionic bonding is basically the transformation of electron from positively charged group to the negatively charged group. To make it even more simple, we could say that it is transformation of electron from a metal to a non-metal. We have read that a metal is known for the sake of donation of electrons. The more something donates an electron, the more you could say that excellent metal it would be, and also they would be the best conductor of electricity as well. While non-metal, as we have heard, we have studied that they are always going to accept the electrons. So simple idea what we have discussed so far, that ionic bonding is simply transformation of electron from a negative, from a positively charged group, or from a metal to a non-metal. So simply, the best example of metals is that group number 1, 2, they are known for the sake of transformation or donation of their electrons. Likewise, sodium that belongs to group number 1, generally it contains 11 electron in its outermost shell. It would feel happy to donate that one electron. The another amazing idea is that if we don't know how to judge how many electrons are going to be shared or donated by each group, simply all members of group number 1 are able to donate one electron at a time. So they are going to give one electron in one go. When it comes to group number 2, they are able to, all members of group number 2, they will donate 2 electrons, and that is why they are going to have +2 charge on them. Now, another thing is that when it comes to group number 1, Na positive is the best example of them. And when it comes to like group number 2, it is magnesium. So magnesium, which is Mg2, it will be able to donate 2 electron in one group. Likewise, when it comes to group number 3, they are able to donate 3 electron generally. Now, how they would donate 3 electrons? Simply aluminium would be the best suitable option for it. Simply aluminium would donate 3 electron, and the charge on aluminium would be Al+3. So before starting the detailed discussion, we will see how the phenomena are going to take place. So when it comes to sodium donates 1 electron, and he feels best to react with group number 7 element. Although it can react with although not generally all the non-metals, but simply when we try to make its bonding with chlorine, we don't have any need to put on 2 or any numeric thing along with it. Why? Because they always react in 1:1. So simply sodium is able to donate 1 electron, and chlorine can accept 1 electron. That is why we will never ever find any number at anywhere else of this. Now, meanwhile, if I place magnesium, who is belonging to group number 2, now when magnesium reacts with chlorine, things get bit different. Why? Because magnesium is able to donate 2 electrons, but what is happening? Chlorine can only accept 1 electron. So where would other electron go? So that is why we will add 1 more chlorine. So the things got easier now. It will become 1:2. Why is it 2 and why is it 1? Because it is 1 magnesium who is satisfying, or who is donating 2 electrons to 2 chlorine. Simply the donor is 1, but its ability to donate electron is that it is able to donate 2 electrons. That is why we make it 2 ratio or 1:2 basically. Okay. And next thing is going to be okay. Now, what is given in the book, they're saying that sodium chloride is probably known as the best example of the ionic compounds. It is simply one that is held together by the ionic bonding. Why is it known? Because simply transformation of electron is something that is quite easier. It is a general reaction taking place between one metal, one non-metal, or simply one positive and one negatively charged group. Magnesium oxide, calcium fluoride, zinc bromide, they are all the best example of this scenario. Okay, now next thing would be that there are two exceptions to this scenario. this topic that there are two ionic compounds that do not contain a metal. For example, those containing the ammonium ions, such as this thing, we will look at this later. I mean, simply in that case, we will make a sense that one of them would be more electronegative. It will be accepting electron, and other would be acting as the electropositive group or least electronegative group. So simply their difference would be that much higher that it makes one thing to act like a metal. So although it would not be a metal, however, it would be forced to be to behave like an atom due to the difference in their electronegativity. Okay, now when a metal such as chlorine, it combines with a metal, when a non-metal such as chlorine, who is a halogen who belongs to group number 7, who is really electronegative element. Now, when it combines with a metal who belongs to group number 1, they would give rise to sodium and chlorine atom. So simply they would be trying to attract each other. As we have already discussed that when it comes to electronegativity, all electronegative elements are really, really attractive. They try to attract or grab electrons which are present in the electropositive elements. Now, next thing would be simply chlorine is a non-metal. Also, it is a good electronegative element. Chlorine would try to accept anything. It would try to attract electron nearby it. That is why sodium feel happy to donate. Chlorine feel happy to attract the electron. Now this is the point when there is a chlorine who is having uh, so simply there is an odd number. Another concept is that stability is always related to odd numbers. When something contains odd number of electron, it means it is unstable. Stability is related to even number of electrons. Now, when we look up to this thing, both these guys, the sodium and chlorine, they contain odd number of electrons into their outermost shell. So sodium, there are two possibilities to convert them into even number. Now, what is it? One should donate, others should accept, so that one would be even, also would be in even numbers. Now you will see that sodium is a metal, and metal feel happy to donate. Definitely, it will donate its electron to this fluorine. So sodium will get rid of this extra shell, which is causing him to suffer from instability. It will try to donate that electron, and after donating this electron to what is it? Yeah, after donating its electron to chlorine, it would be stabilizing itself. Why? Because it is getting rid of the extra available electron. So sodium is donating an electron to chlorine. After donating this one electron, sodium get rid of the extra available shell, which was occupied by the one electron. And simply, if we just donated this electron to chlorine, now there is nothing to share or donate. Basically, simply it get rid of this extra electron. That is why we used to say that the size of a cation is always smaller than the original size of an element. Why? Because that positively charged group, that cation, that sodium, or that metal will keep on donating its electron, and that non-metal will keep on accepting the electron. That is why a cation is always smaller than that of its metal, while an anion is always bigger than that of its non-metal element. Why? Because metal is donating and non-metal would be accepting that given number of electrons. Okay, so we can see cation is smaller. Earlier it was containing simply 3 shell and it was having 11 electrons. Now it contains 10 electrons and 2 shells are there. Next thing would be, although number of shells didn't increase, but the number of shells right there increases. Another amazing fact is that both of them, after suffering from this exception and donation, donor would be positive, acceptor would be negatively charged group. Okay, after donating or accepting the electron, the things are going to attain some sort of charges, and now they are going to be termed as ions basically. So the donor would be termed as, it would be called as a cation, and acceptor would be termed as an anion. So when a positive one is called as cation, the donor basically, and it is a part of a metal. Now, acceptor would be called as an anion. It is being attained by it is being a part. It is a part of the non-metal basically generally. Now, when an ionic compound is formed, electrons are transformed from a metal atom to a non-metal atom to make it positive and negative ion. Ionic compounds are having ionic bonding, obviously, and what it is the electrostatic attraction between the charges. It means electrons are going to attract each other. So simply, things are going to behave like one is donating, other is accepting. They are doing what? They are attracting their electrons. Okay. Now, ionic bonding is often showing this dot cross model. We'll see it later on. Now, when it comes to this scenario, what an electrostatic attraction is, it simply means that positively charged particles attract negatively charged ones. So simply, this it is attracted by negatively charged ones. So negative is going to attract electrons of sodium, and now this is going to be termed as electrostatic forces of attraction. So that makes a sense. You can clearly see that one sodium is surrounding by this number of electrons. So every sodium is surrounding from the four corners by the chlorine atoms nearby. However, when we keep in a lattice arrangement, one sodium is surrounded by six chlorine, and one chlorine is further surrounded by the sixth sodium atom. We'll discuss it later on. Okay, now the next point is going to be how a certain number of elements are going to behave, so the case is same when it comes to magnesium. They contain two electrons in their outermost shell. When there are two electrons in their outermost shell, okay, when there are two number of electrons in their outermost shell, magnesium contains this one and this one. Now it have to get rid of these two electrons. So you should be clear that magnesium is going to get rid of this one and this one. It came over there. Now magnesium can donate two electrons, so oxygen can accept two electrons. So that is why we didn't put any number onto them. We will make it MgO in a simplest way. So now they're going to be Mg plus 2y because Mg is donating two electrons and oxygen is accepting two electrons. That is why it would be O negative 2 ions onto it. So simply the cation is donating 2 and anion is accepting 2. Next thing is going to be when it comes to the arrangement, each of the atom has a noble gas electronic configuration. Why we used to say this noble gas electronic configuration? Because in this case, we have made noble gas as a standard of stability. So simply, when we say that something is donating or behaving as a noble gas, it means it is stable. Its outermost shell is stable, just like that of a noble gas, because noble gas is neither reacting, it is neither donating or accepting any electron from anything else. That is why we call it as a inert gas. So noble gases are inert in nature. Why they are inert? Because they are not they are neither accepting nor donating any electron to anything else because they are stable in nature. So for the first 20 elements, they gain or they lose or gain electrons so that they achieve a noble gas electronic configuration. Now, group number 1, 2, 3 will try to lose electron as per their group numbers, and 5, 6, 7 like group number 5 in which nitrogen is there, it will be accepting 3 electrons. Oxygen for group number 6 will accepting 2, and group number 7, which is a halogen family group, they will be accepting 1 electron per reaction. Now again, it comes to group number 3, aluminium. So it contains 3 number of electrons into it, and it easily get rid of 3 electrons gradually. So simply 3 electrons are removed, and it would be removing this shell. So upon removing the shell, it will get rid of this outermost shell. Earlier there were 3 shells. Now it would be left with the two shells, and outermost three electrons will be removed from it. Okay, now when it comes to nitrogen, so nitrogen contains three electrons in its outermost shell. After accepting the three number of electrons from aluminium, sodium, nitrogen will be stabilized. That is why we can say that aluminium is donating three, aluminium is donating three, and nitrogen is accepting three electrons. That is why they're having same bond among them. Okay, next point would be isoelectronic. Okay, isoelectronic thing. It means that things which are having same number of electrons. So sodium forms an ion which is whose electronic configuration is 2 and 8. It becomes isoelectronic with the neon. Why? Because the natural configuration of neon is 10. Sodium, upon reacting or upon donating one electron, it will become isoelectronic with the neon because both contain 10 number of electrons in their outermost shell. Next point is going to be elements in the group number 1, 2, and 1, 2, 6, and 7. They always create ions that are isoelectric with the nearest noble gas. Just like rubidium, which is in the group number 1, and it has an electronic configuration, and it has one electron in its outermost shell, and it will donate or lose its outer shell electron to make it be a +1 ion. Next thing would be it has the same number of electrons such as a krypton. So it's simply an example that rubidium belongs to group number 1 if it removes its outermost shell electron, like if it removes one electron from its outermost shell, it will simply when rubidium is present, it will donate one electron. After donating that one electron, it will be stable as stable as that of the krypton. So simply they are saying that upon donating electron, these group number will attain configuration as that of the nearby noble gas. Iodine, who belongs to group number 7, who's really like electronegative simply. Now what it is going to do? It has 7 electrons in its outermost shell. If it receives one electron, when it creates, when it transforms into the, okay, if it receives one electron, it will become -1 charge onto it definitely. So it upon doing this thing, it will attain configuration just like that of the xenon. However, there are a lot of the common ions that doesn't have any noble gas type configuration, just like iron. Basically, iron have two type of. Iron is a transition metal, which is having two like electronic, having two oxidation numbers onto it. They are engaged in rusting, which we'll see later on. So they are simply, we will see them later on, but however, it is not mandatory for everybody who is doing ion configuration to make a matchup with noble gases. So here are some other example of the ionic bonding, such as lithium is there, lithium chloride is there. When lithium chloride are going to react with each other, we should be clear that lithium is able to donate one electron. Fluorine is able to accept one electron. So definitely the ratio would be 1:1. So lithium contain one electron right there. And what it will do, it will simply pick up that one electron from its outermost shell. Let us say it just donated, remove one electron. After removing one electron, the carine of lithium will look like this. When it comes to fluorine, it will be accepting that one electron and it will be placing it right there. So after accepting electron, it would be negatively charged. So that is how they are going to behave, like one is the electron donor, other is the electron acceptor. Upon accepting electron, they would behave like they would be creating some ionic bonding between them. Next point would be simply lithium atom has one electron in its outer shell that is easily lost. So if lithium will give up one electron, it will also get rid of that shell also. So we can say that the donor or the metallic, the cation of a metal is always smaller. However, the size of an anion is always bigger. Okay. So lithium chloride is held together by the strong electrostatic forces of attraction between positive lithium ion and negatively charged fluoride. Now, here is a jumbo structure, but if you are clear with the concept, it will be nothing. So we can say that here is calcium. You should be clear that calcium is eligible or it has power of donating two electron. So it contains one electron right there. It contains one chlorine right there. So here is a calcium. Calcium is donating one electron to this chlorine at there. And when it comes to calcium, it would be donating one electron to this calcium. That is how we can say that the donor is donating two electrons. That is why the charge on the donor would be positive 2. Why? Because it is donating two electrons. However, the acceptor would be having, since everybody is accepting one electron, so definitely the charge on them would be -1. Other would be having also a charge of -1 on it. Now, next one is going to be the calcium atom is there. It is having this configuration. The two electron would be in outermost shell, and every electron is going to be donated to the chlorine atom. Upon accepting the chlorine atom, the formula would be changed into CaCl2. Everybody is accepting one electron from the that given chlorine. So the ratio for uh, calcium chloride would be 1:2. So simply chlorine is donating calcium is donating two electrons, and chlorine is accepting each chlorine is accepting one electron. So here is the thing. Okay. So we can say that here are some certain group number. I mean, like there are certain period numbers. What they are gonna do? They are going to take the groups in the group number one. The charge on group number one element would be +1. Right there. Example for it would be sodium. So it would be Na plus. For the charge number for group number 2 would be +2. As per its group number 3 would be +3. Group number 5 would be -3 because it is accepting 3 electrons. Oxygen would be accepting -2. And bromine would be accepting -1. So they will create their bonding by considering this thing, by making this ratio as same as it is as per their group numbers. Okay. Next point is going to be so all metals create positive ion because donor will always be the positive and acceptor will always be the -1. Now, simply if we name them as simply lead 2 oxide is there. What does this thing mean? Lead, lead is simply donating 2 electrons to oxide. So we place this number in a Roman counting. So to mention that lead is donating 2 electrons to oxide. Why? Because oxide is accepting 2 electrons. Same way, iron 3 chloride. So simply we can clearly see that one chlorine would accept one chlorine would accept 3 electrons. So the number on them would be, the formula for this thing would be FeCl3. So the simplest ratio for the number of atom would be 1:3. Why is it 1:3? Because donor contain one atom of donor can donate 3 electrons. So simply it is +3. However, the acceptor, every chlorine could accept one electron each. So we have to triple up the number of chlorine atoms. So we can make it like FeCl3. Okay, next thing is gonna be copper 2 sulfate. What does that thing mean? That sulfate, the formula for sulfate is SO4 negative. So you -2. So you should be clear that this SO4 is able to accept 2 electrons. So the idea makes as simple as it could be. One chlorine copper can donate 2 electrons right there. So, and one sulfate could accept two electrons. So definitely it became like this way. Okay, next thing is gonna be mm, okay. So we can clearly see that, but put a charge on this thing. The charge on this thing is going to be positive. Why? Because silver is the donor. For hydrogen, positive charge should be there. For ammonium, the charge should be positive. Okay, so for there, they are the negatively charged groups and the charges are mentioned. So you should be clear that OH, the hydroxide ion, is able to accept one electron. However, the current charge on this guy would be -1. In the same way, we can make this thing to react with each other. Now, here is a key point when it comes to a key point. What they are trying to say is that ammonium chloride is there. When it comes to an ammonium chloride, it is an example of the ionic compound that does not contain a metal. Definitely, there is no clay metal over there. But there is an ionic bonding between this thing, ionic like ammonium and chlorine. How is it possible? So, simply, however, also covalent bonding. Really? Well, we can simplify this statement that in this case, there is a huge difference in electronegativity, and that is why these two guys are holding each other strongly. However, the type of ionic bonding what they are talking is about is really not an ionic, it is a polar covalent bond in which both the sides, the metal and the both the sides are having uh, a huge gap in their electronegativity that makes one side positive, other negative, so that they could stabilize each other. Now, here's another thing that do not confuse things like sulfate or sulfide. A name like copper 2 would be copper 2 sulfide is there. It means that it contains copper and sulfur only. Okay, so they contain two types of item in them, copper and sulfur, as per their statement. Now, any ide means that there is anything complicated. So it means that when it comes to copper and sulfur, they are reacting with each other. We would only anodize sulfide. However, when we place ide with them, it means that they are solely or purely two elements attached to each other, just like NaCl. Now, okay, copper sulfide means that there should be Cu plus 2 or okay, sulfide means there should be, I mean like anything if it ends with IDE, it means that there are two atoms bonded with each other. Only two number of atoms are attached with each other. However, if it ends with 8, ATE, it means there might be 3 in number. So if I place it like sulfide, copper sulfide, it means that there is one copper, one sulfur. However, if I place 8 with it, this 8 means that there are more than 2 or majorly there are 3 atoms attached with each other, just like CuSO4 is attached with each other. Next thing it would be yeah. When it comes to this formula, simply there is Ca plus 2 and chlorine is there. Since there is chlorine can accept 1 and calcium can donate 2. So in order to stabilize this thing, we should increase the donor. But we can never ever make it as okay. We can never ever make it as Ca2OY because if we are doing it, let's say we would be saying that if it is Ca2, it means that there are two calcium atoms. So it looks like they would be donating 4 electrons. However, this is not that doesn't make any sense. So we would always refer it as CaOY because it's simple. The ratio should be similar. Donor can donate 2 and acceptor can accept 1 electron or 2 electrons only. So that is a sense of it. Next thing would be a giant ionic structure. What is it? It might contain a lattice. Lattice is anything that is having proper arrangement of positive and negative charges via electrostatic forces of attraction. So here is it. This is the giant structure we were talking about. Simply you can see that there is one sodium right there. This green color thing is chlorine, and the smaller positively charged thing are the sodium. So we can clearly see that one sodium, even one chlorine, is surrounded by six number of chlorine atoms. How we can sense it? How we can make a judgment on this statement? Let us say this black colored thing is sodium. This is chlorine. This is sodium number one. This is going to be the 2, 3, 4, 5, and this will be the frontal 6 one. So in the same way, sodium is also be surrounded by different number of electrons on 2s. So simply everybody is surrounded by 6 sodium, and one chlorine would be surrounded by 6 sodium, and one sodium would be surrounded by 6 chlorine atoms. Here is the giant structure. What does that thing mean? The structure of sodium chloride is described as a giant ionic lattice. We use the word giant when it doesn't make sense, but that is a huge structure. So all the sodium ion in the structure would attract all the chloride ion. Why? Because they're having different charges on them. So it in a collective way we can say that they are making a giant structure. Now, when it comes to the magnesium oxide, a magnesium oxide contains magnesium ions. Magnesium ions will have a formula like Mg plus 2, and oxide ion will be O negative 2. It looks like they're just like the ratio of 1:1, just like it was in sodium and chlorine. The only difference in them is that they are held together by stronger forces of attraction. Why? Because for sodium chloride, they were being attracted by 1:1. So simply one sodium was attracting one chlorine atom. When it comes to a magnesium oxide, the attraction got doubles in number. So earlier it was one. One sodium was attracting one oxygen. Like one magnesium was attracting one oxygen. However, the ratio was same, but they were engaging or involving two electrons. However, in sodium, they were being attracted by one electron game was there. So double and single was the main key idea of the difference. I hope that will be cleared so far.